The funny thing is, the next thing I have to do is drill a gazillion holes in all of this plate, and here it is sitting on a workbench with a bunch of drill heads that aren't hooked up. Hey drivers, we've got something a little bit different for you today. Behind me is a 4-head Verispeed drill press with a heavy cast iron base on it. We picked this up at an auction last fall. It's a super cool piece of machinery here. What we want to do today is see if at least one of them works. So we've picked up some cable, a couple of connectors. It's 3-phase, so this is going to involve the 3-phase rotary converter that we have for the mill. We'll need to check to see if the motor is wired for 220 or 440. These 3-phase motors commonly have wiring for each of those voltages. And just mind our P's and Q's with conductor size and current draw and all that. So let's get started here, and hopefully by the end of this thing, we're going to drill some holes with one of these drill heads. Peeking down into the top of one of these, we see the Verispeed feature. Very common design. It's kind of like the cold saw that we refurbed a couple of years ago. This pulley actually gets wider or skinnier, and in that order, it gets smaller to this belt or larger to this belt. This pulley back here is spring-loaded and it reacts. So of course the length of the belt is fixed. As this one gets smaller, for example, that creates slack in the belt, which allows this spring to make this pulley get a little bigger. So it's kind of double the action, right? As you speed things up and slow things down. All of these belts look pretty good. I think one of them was showing somewhere. Maybe it was this one. Starting to get a little bit of cracking there. This is the one I was thinking about using. Of course, each head can go up and down with this crank. You just have to loosen these here. And I dug up an old Palmgren vise that, at least for now, will be good. What I'd like to find is a used Kurt. I watch them in the auctions and they always go for way more than I want to pay. But, you know, that's the good stuff. Until then, this will do us fine. The idea here is that you set up your work and you can move it from one setup to the next. So a small drill bit, larger drill bit, or a drill bit and a tap for power tapping or whatever. These quills here are a Morse 2 taper. So that's this. There's different sizes. I see a lot of MT3s, but thankfully my old lathe uses an MT2 because that's what goes in one of these. So we have at least one chuck that we can use. Tapers are pretty cool at doing their job there. So when we get one of these fired up, we should actually be able to drill some holes. This is what I have to power it. It's a small 5-horsepower rotary phase converter. I've rigged up its output on a connector, so 3-phase power comes out of here. It's on a 15-amp breaker, so that works for what we're doing. We're going to be using some 14-gauge wiring for the drill head. So our conductors, even though this is oversized for what's happening, like way oversized, our conductors will be appropriately protected by the 15-amp breaker on the 3-phase output of this converter. Going into it is a different ball game. This one has 30-amp fuses in the disconnect, and we'll be using 30-amp spec inlet cord. So a 30-amp plug and 10-gauge 4-conductor wire. We don't really need 4 conductors here, but I'll probably wire this differently another day. And it'll be nice to have that wire for something else. Just on a side note, I'm using SO cable instead of the more common SJ cable because I want that higher voltage rating. This is 600 volts instead of 300 volts. I've got several machines here that run on 440, and so it's starting to make more and more sense for me to just wire the shop at that 3-phase voltage. This is like in the future here, but just planning ahead, it kind of makes sense to just do that. And for machines that have the option, I'll just wire them for the higher voltage and plug it in directly to my infrastructure at that time. There's going to be a machine or two that absolutely must be running on 208. So I can wire those special or use this thing. This is a transformer that I got thrown in on a deal recently that takes 480 volts and steps it down to 208. It's already connectorized with some pretty common twist lock connectors there. Like, this is a pretty cool find. It's 15 kilovolt amps and it's gonna serve the purpose, especially if we only have 1 or 2 machines that would need such a thing. In the end, it'll be cost effective because when you double the voltage, you split the current in half for a given amount of power. That means it'll save me on wiring costs. I won't have to get as big of conductors, and I'll have less power loss, kind of a trade-off between those two benefits across the entire system. For today's purposes, we just have that one phase converter back there. We're going to keep it real simple. We're going to take the 15 amp 3-phase 208 volt output and wire it into a connector on one of these drill heads. So you ask, how are we going to do that? Let's take a look. We made this skid a few days ago. I stuck it out a little bit far in the back just so this thing is not tippy. So we ended up with a nice stable base for it and some heavy duty wheels to make it easy to roll around. What you think there, Wally? Good looking. Okay, each one of these drill heads has its own power box. This is the power inlet and it has seen much better days, so no, I am not going to power up that nightmare. Underneath this outer jacket, the insulation on the individual conductors is coming apart. Let me see if I can show you. Yeah, check that out, right there on one of the hots. It's just given up. It's so old that the insulation is tearing off of the conductors. Probably got tugged on a time or two as well. Here's one that's super scary. Just as it's installed, you see the bare wire right there. That's to be avoided. Now on the back are a couple more cables. One of them goes directly to the motor. So that's the output of our electrical box to the motor. The other one goes to the switch. So it kind of snakes up here and through the unit itself. That's going to be a little more fun. But I think we need to replace that while we're at it because all of this stuff is the same age and what we've seen on the inlets is a real problem. This is an important clue. This wire is supposed to go to the appropriate terminal for whatever voltage this motor is wired at. And we can see here that it's 230 volts. The way to really know if you can make out this diagram here is to get inside here and see which of these configurations it's wired for. This is very likely a 9-lead motor, and if I can get in there and see that 4, 5, and 6 are tied together, I'll know it's wired for low voltage, just like that transformer back there tells us. If it's wired for high voltage, well, then we have a mystery on our hands. We're going to see that 4, 5, and 6 are tied to other wires, not each other. But we'll be following this to figure all that out. All of this is 14 gauge wire, 4 conductor, so I've picked some of that up at the electrical supply, and that's where we'll be focusing our efforts. I did want to make sure that it would fit through a clamp that will fit in these knockouts. Without any modifications, we are limited to a 1/2 inch knockout, and that doesn't make for a very large clamp, but thankfully this 14 gauge 4 conductor does fit in a clamp that fits through that knockout. Just one of those little details we've got to confirm. Of course, we also want to put a big connector on the rotary converter, so I picked up some 10 AWG 4 conductor. Here's the obligatory disclaimer. This is just for my own knowledge and for your entertainment. You got to figure this stuff out if you're going to do electrical on your own. A lot of folks probably just shouldn't. Here's that rating I was telling you about. SO cable instead of SJ cable. It's giving me this 600 volt rating. So this will be future proof for when I expect to have a whole bunch of 440 volt stuff. Like for this beast and the LeBlanc lathe and the big Thompson surface grinder. Let's go for an early win and see if we can get that thing up and running. Really all we should have to do is wire up a power cord and get it plugged into 240. Pro tip, when you buy wire, they always use electrical tape to bundle it, which is handy, except that it always leaves sticky crud on the cable. So to minimize that, take the E-tape off as soon as you can. Get this cleaned up. This is standard hardware store stuff. This is just a straight contact NEMA plug. That'll do either 30 amps or 50 amps, depending on what you put in this position. It even tells you, hard to make out because I cut right through it, but this is the L-shaped one. That's the one I'll be using at 30 amps, but it's just as good for 50 amps if you put the straight pin in all 3 current carrying conductor locations. Oh, well, it's a good thing I didn't steal this thing, right? I'm using SO cable, which is a bit thicker, so I doubt I'm going to need these, but they would be useful for skinnier cable. I do not want to crush my cable, so in my case, I want to take all of that out. Okay, silver screw is the neutral. The brass colored screws are hots, so the 2 on the side there, and then the green is of course ground. Here's that L-shaped pin. I'll go ahead and get this involved right away so I don't forget it. You know, I've never really thought about it, but I wonder if it's possible to put this in there upside down. That'd really stink. Let's see. Not without breaking it, so that's cool. We want to do this all nice and tidy like, so I want each conductor to just go as far as it needs to get to this terminal. So the white wire will be the shortest, the green wire will be the longest, and then 2 hots will come out here. Sometimes you get a little gauge somewhere on the connector. Not in this case. Or maybe some measurements in the instructions, not on the bag. Well, you can figure it out easy enough, but if they give them to you, you might as well use them. There we are. So my white wire will be 1 inch. Can't say I've seen that before. The hot wires will be 1 4/5 of an inch, slightly more than 1 3/4, and the green wire will be 2.5 inch. Okay, easy enough. So I'm going to cut my outer jacket back 2.5 inches. Our green wire should be okay. It should be at 2.5 inches. Actually, that's 2 3/4, so we're going to take a little bit off. Don't worry, I have a cable stretcher just in case we cut too much. So we're going to do a thick 1 3/4. See if I can get something that'll cut a little better. And I want to do the same thing to the other hot. And then the neutral is just a straight up 1 inch. That guy's going to be pretty stubby. Alright, looks like I want to strip that much. I want to make sure that I clock the pin correctly on each wire when I tighten it down. Let's start here. Like, I don't want to get this one upside down, for example. Which is totally something I'd do. So by paying attention to those measurements and how the wires are clocked and all that, this part goes a whole lot smoother. Okay, it doesn't look like anything's rubbing. Let's get that out of there. This is pretty important too. this is my strain relief here. So the outer jacket goes beyond the clamping portion of the connector. This thing will last longer like that. Actually, you know what? That's not as snug as I'd like it. Let's see what we can do with these. A lot of times these little inserts can be used in two different positions, and that's the case with this connector. It was shipped like that, which is the tightest position, but there's another slot back here that's a little deeper, and I think that's going to be the one for us. So if we look at it here, see how that obstructs the opening that much? And then when we slide it to that second one, the opening is not quite as obstructed. So this is going to be cool. We're going to get a little bit more snug on our cable, hopefully without crushing it. There we go. And so that becomes our new target. Up here is where the clamping force is. And again, our outer jacket goes past that. So this cable will last longer and be, whoops, less dangerous. I just dropped my little thingy. There we go. All right, let's get one started here. Okay, I'm going to snug that down in a second. We really want to close this all the way, and that's why the choice of where that insert goes or doesn't go is so important to make ahead of time, because now we're just going to keep going until the connector is closed. Not all connectors are like that, but this one is, so I think we're going to be in good shape and not in danger of destroying the conductors. We really only need to go 3 places. I'm not going to need the neutral for this end of the cable. I just wanted that cable to have it for future use. For today, we're just going to put the 2 hots here and the ground in there. There is no way our cable is going to fit through that tiny little cable clamp. This cable clamp is in a 1/2 inch knockout. I'm going to need a 3/4 inch knockout. So we'll have to enlarge this hole here by going to the next level up knockout. Let's get this out first. Here's the way we do a lock ring. Unless you have a pair of lock ring pliers. Can you believe something like this exists? There you go. All right, hots through the fuses, cool. Ground, very important, cool. Let's close it up. Okay, we're plugged into 240, meter set on AC. And we've got 243. That'll work. I don't have anything plugged into the converter, so it's not under load, but we're all set. For the uninitiated, this is just an idler motor, so there's not even an axle shaft sticking out of it. It's just sitting there spinning, creating what's called the manufactured lathe. We'll go ahead and deal with our connector. This is a twist lock, rated for 250 volts, 3-phase power. Only a 4-pin, so there's no neutral here. Just the 3 hots and a ground. That will work for what we're doing. It's a little bit of overkill as far as the ampacity is concerned, but that's okay because all of the conductors, including these, are properly overcurrent protected. Meaning I've got a 15 amp breaker and I've got wire capable of 15 amps. It's okay if this plug is capable of more than that. Now where a person gets themselves into trouble is if they plug this into a 20 amp source and wire the other end to a 20 amp load, meanwhile having underrated wire. That would be a problem, but we're not doing that. Another way to state all of that is the idea that with portable power distribution, you can wire things for the intended load. You cannot get away with that on permanent installations. Just going to get that out of the way. Okay, once again, we have brass screws for the hots, all 3 of those, and then green for the ground. It's going to be easy. All of these just need to be equidistant. So actually, let's get that. How's all this going to sit in here? See, I got to do that thing where my clamp bites down on the outer jacket. So I don't want to strip off too much outer jacket. So it'll sit in there something like that. Now we can see pretty easily how it lines up. I'm not going to take off too much outer jacket at all. Really just enough to get those wires spread apart and into those contacts. Oh, do you see what I did? Look behind the connector. Good thing this is going to be a short cable. I'm going to have to put that on from the other end. That completes all of the high current stuff. The rest of it is just the control cable that goes to the stop and start buttons. We're going to replace that too, but I think this might be a good time with reasonable management of risk to try this thing out and see if it'll even start for us. All right, I don't know if this is going to translate on video very well, but it's going the correct direction. That's good. Perhaps you expected that, but it doesn't always happen. About 50% of the time, a motor like this will spin backwards, and so the cure is to switch 2 of the power leads. We lucked out and we're in good shape. Okay, last wire to replace is right here, and it goes all the way to the front of the machine. So let's get this out first and then we'll go up front. dug up this old pomegranate vise here that'll do for a trial, but really I need to find something a little bigger. I'd love to have a Kurt. I've been watching for one for a long time, and they just get priced out of my budget, but I'll nab one at some point. This is the number 2 Morse taper from the lathe. I'll need to find at least 4 of these to have this fully equipped in the future, but this will work for today. We're going to try out some 1/4-inch holes. Not bad. Not bad at all. We're going to be able to work a lot faster on this drill press than the old mill drill. Now it has its place. It's wonderful for high precision, but here if I'm going to do a bunch of holes and I don't need absolute precision, I can line them up by eye pretty quick and plow through them. So this is pretty cool. Also, it's a great workbench to work on. I'll be able to set up several different bits, and if one piece of work needs a bunch of different holes or stepping up the sizes or whatever, just bing, 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 just go down the line and get her done. So this will be a lot of fun to use this. Is it necessary? Nope, not at all for a home shop, but is it cool? Yeah. The reason I wanted a Verispeed was not just for the convenience of it. It's really the realism. Meaning, I'm more likely to select the correct speed for whatever size drill bit I'm using if it's really easy to do so. In fact, on the mill drill, I can't remember the last time I moved the belts across those step pulleys to get to the proper speed. I just kind of found something that works as a general purpose for everything, and I usually just leave it there. So the holes are not going to be quite as accurate, the tool bits aren't going to last quite as long. This way I'll get better results because I'll be more likely to use good practices when drilling holes. Know thyself, I guess. So now we have that. It's just a matter of having the discipline to dial in the correct speed. Over time, I'll get to know those. It's something called surface feet per minute if you want to look into it a little bit more. And we'll get much better holes drilled than we would without paying attention to the speeds. So that's what it's about, folks. We're keeping the project alive and driving the dream. We'll see you in the next one.